First of all, pressure at a point inside an accelerating liquid. Pressure at a point inside an accelerating liquid. Consider this situation. This is an elevator accelerating upward. This is a liquid, we may consider water, okay, present in a bucket. What is the pressure at this point? What is the pressure at a depth of h? What is the pressure at a depth of h? How do you calculate pressure? All of you know P equal to rho G into H. Do you remember the calculation? How do you get P equal to rho G H? We will do similar calculation to get the pressure here. This is the container. We will consider some volume, a liquid column of height h and its base area is a force on the base, force exerted on the base of area A equal to weight of liquid. What is the force? Force exerted on the base. This is accelerating. How much force is acting? For this, I will switch over to, we will study this with respect to an observer, with respect to a non-inertial observer. With respect to this observer, pseudo force will act on it. Non-inertial frame observer, with respect to this observer, pseudo force will act on the bottom. So what are the forces acting on the bottom? Forces that are acting on the bottom from top, mg. Mg is the weight of the liquid column. Then this is accelerating upward. So pseudo force m into, okay, this liquid column, its own weight is acting on this liquid column. Pseudo force m into is acting. That pseudo force is trying to push the liquid column downward. So mg and ma, these two forces are acting on the bottom and they have same direction. Okay, so force exerted on the base of area A, downward force, mg plus m equal to m into g plus a. And what is the mass of the liquid? Mass of the liquid, volume of liquid column, density of liquid, and this force is F. Volume of liquid equal to H into A into rho L. Okay. the mass of what? M is the mass of the liquid column. I have shown that liquid column. On that column, mg is acting downward, and we are considering non-inertial frame to study the pressure. So ma is also acting. So total force acting on the base is mg plus ma equal to m into g plus m. Mass of the column is volume of the column into density of liquid equal to h, and volume of the column is height into area of cross section, or F by A. Pressure is F by A now. Or pressure of liquid equal to G plus A if the body goes up, G minus A if the body goes down. If it accelerates downward, minus; if it accelerates upward, plus. So pressure of liquid is not H into rho L into G, it is H into rho L into G plus A. Okay? Now I'll study the buoyant force in an accelerating liquid. First I will ask you, what is the origin of buoyant force? What is the origin?
Force exerted by weight of the displacement.
Origin is, you will have to know what exactly is the origin. You know that buoyant force is equal to weight of displaced liquid. But what is its source? Consider a body. This is a body immersed in a liquid. On this surface, pressure P1 is acting, and on this surface, pressure P2 is acting. This is H. And area of cross section is A. A equal to area of cross section. So what is the force acting on the upper surface? P1 into A. What is the force acting on lower surface? P2 into A. Which force is greater?
P2.
Because P2 is greater than
P1.
This is the origin of buoyant force. When you immerse a body, then on the lower surface of the body, a greater force acts than the force acting on its upper surface. Okay, so if you immerse this type of body, will there be much buoyant force? Because its thickness is so small that pressure on upper surface is almost same as the pressure on lower surface, and the buoyant force on such body will be zero. Okay, but the volume of the body is not small. Volume of the body as such is not small, but in this position, but on this body, buoyant force will be zero. That is because the force on upper surface and force on lower surface are almost same. And it all depends on the thickness. Greater the thickness, greater will be the buoyant force. Because more pressure will act on its bottom. Okay? Now, we'll have to find the buoyant force. This liquid is accelerating upward. So buoyant force AB on the body, buoyant force acting on the body equal to P2 into A minus P1 into A. Okay, this is the origin of buoyant force. I am using that, P2 into A minus P1 into A equal to P2 minus P1 into A. How much is P2? Just now we have derived an expression for pressure at a depth in an accelerating liquid. So P2 equal to, let this be capital H, okay? This capital H, and take this to be small h. Okay? So what is the pressure at this depth? H into rho L into G plus A minus P1 small h into rho L into G plus M into A. Okay? Equal to H minus H into rho L into G plus A into A. Okay? Then H minus H into A into rho L into G plus A. What is H minus H into A? Volume of displaced liquid. So this is equal to volume of displaced liquid into density of liquid into G plus A. This is a B accelerating. Okay? Put G plus minus A.
So displaced liquid means a solid of the body.
H minus H into A is the volume of the body. You may write volume of the body. If the body is fully immersed, then volume of the body and volume of displaced liquid are same. And otherwise, buoyant force equal to volume of displaced liquid into rho L into G. Here, volume of displaced liquid into rho L into G plus minus C. If the body is not fully immersed, volume of displaced liquid. Okay, for example, the body is floating in this state. How much buoyant force is acting on it? We will use volume of displaced liquid because it has displaced some liquid. Volume of that into density of liquid into G plus minus A. Okay? The elevator is accelerating upward with an acceleration A from its ceiling. A block of mass M, from its ceiling a block of mass M is suspended which is immersed in a liquid of density rho L. In a liquid of density rho L, find the tension in the suspension thread. So you have to find the tension in this. Achha. So first I will draw free body diagram of the body. The forces are mg, then buoyant force Fb, and the string also exerts a force E. These three are the external forces acting on the body. And what is the net external force? Net external force equal to mass of the body into its acceleration. In which direction is it going?
Upward.
So the total force acting upward is greater than the total force acting downward. So for the immersed body, P plus Fb minus mg, this is the net external force. This is equal to mass into acceleration, or T equal to m into g plus a minus mp. Okay, m is given, so I will not write m in any other form. M into g plus a, m is given, g is given, a is given. Only buoyant force. Buoyant force only in the last question I discussed. It is equal to v dl rho l into
G plus A.
G plus A, volume of displaced liquid equal to volume of the body. Equal to G plus A, M minus V rho L. Okay? In this container there is a liquid. Initially the container is at rest. It is not moving. The container is not moving initially. Then it starts going horizontally with an acceleration A. Will the surface remain like this? Will it be, this question once came in competitive exam. Will it be like this?
No.
Will it be like this?
Yes.
Okay, so this question came whether the surface will be like this or like this. Now those days are over. Now the question is, how much angle will it make? Angle. Or not, it will be like this or this. What angle will it make with the horizontal? So it will obviously not remain. It will be like this with acceleration. The surface will be like this. Okay, this can be explained easily. If you consider non-inertial frame, then pseudo force will act in this direction. Against the acceleration of the body, pseudo force will act in this direction, and that pseudo force will produce greater pressure. As a result, the liquid will go up. It will go up. If there is greater pressure at this point, then liquid will go up. Okay. So you will have to find this angle theta, angle made by the surface of the liquid with the horizontal. How will you prove this? Very easily. You will consider an element, a liquid element. Is this liquid element in equilibrium? The liquid is accelerating in forward direction, so this element is also accelerating in forward direction. Okay? And if you consider non-inertial frame, this element is in equilibrium at rest. So if you consider non-inertial frame, let us consider a non-inertial frame. How to switch over from inertial to non-inertial? By applying pseudo force. So I am considering the situation with respect to this person. He is our non-inertial frame of reference. So pseudo force, since I have considered non-inertial frame, pseudo force m into a. M is the mass of this element, and then in this direction mg, and what else? Normal force. Who exerts this normal force? Surrounding liquid. This element has more liquid in its surrounding or not? We have taken only a sample, but surrounding, in the surrounding of that sample, there are a lot of liquids. That liquid exerts normal force on this. And this is the direction of normal force. Okay? And in non-inertial frame, this element is in equilibrium. So, we will do what? Resolve this is theta, means this angle is theta. So resolve A into two components, n cos theta and n sin theta. For equilibrium of the element, for equilibrium of the liquid element, n sin theta equal to ma, n cos theta mg, you can see n cos theta equal to mg, n sin theta equal to ma, divide these two, dividing tan theta equal to a by g. Other instances of tan theta equal to a by g, pendulum. I am showing other instances. In a vehicle, accelerating, pendulum will be in this position and this angle theta, and here also tan theta equal to a by g. Another instance, block, angle theta, this is accelerating, and the acceleration has such value that the block is not slipping on the surface. Surface is smooth, but the block is not moving with respect to the surface, means block is remaining in the same position. This is a very important question, and if you remember the result, in no time you will get 4 marks. The answer is again tan theta equal to a by g. What question will be asked to you? For what acceleration of the wedge? For what acceleration of the wedge, the block will remain stationary on the surface of the incline. Okay, for what acceleration A, the block will remain stationary on the surface of the incline. Or for what acceleration A, or minimum acceleration A, the block will start falling downward. What maximum acceleration A, the block will start going upward. Answer is same. A equal to g tan theta. Okay. So for both these cases, okay. So these are 2 and this is the 3rd. Okay. Now we will find the pressure at a point in a liquid accelerating horizontally. Okay.
So banking of product you don't have tan theta equal to a by.
This is the container. Initially at rest. This is given H. Okay. This length is given L. Then it starts accelerating. Acceleration is A at a distance of x, at a horizontal distance of x from its front wall. At a horizontal distance of x from its front wall. At a horizontal distance of x from its front wall. What is the pressure? Find the pressure at this point. Find the pressure at this point. Okay, and this with respect to this initial reference is this now. With respect to this point may also be given. The depth may be given that this is h. Find the pressure at this point. Due to the motion, suppose the surface of the liquid becomes like this. This angle is known to you. You can calculate tan theta equal to g. In order to find pressure at this point, you will have to know the height of liquid column above this. So this height, you have to calculate this height. Then that height into rho L into G. So you have to find this height. If this goes down by say y, then this will go up by y, by symmetry only. So once you have to calculate y, after you get y, then once you know y, then you know this distance. That will be, this will be h minus y. This will be h minus y or not? Because of this is h, this is also h. This is also h. If this goes down, if this gets depressed by y, h minus y. Once you get h minus y, you can calculate the height of liquid column above this, because this angle tan theta equal to a by g is known to you. So once you get this height, h minus y plus that height, h minus y plus that height equal to height of liquid column, or now this is h now. So h, that means h plus this height, h plus at a depth h to
capital H minus small h plus y.
apply symmetry. This is the initial level of liquid. Now once it starts accelerating, this level on the rear side go up and this will go downward. This was the initial line. By symmetry, if this goes down by y, this will go up by y. Simple symmetry. And this will be the midpoint. Means the whole thing will tilt around about its midpoint. So this is y, this length is L by 2. Okay, we'll have to find the pressure at this point. So we'll have to calculate this height. Okay, so what is the height at this point? Height above this is h plus this much. H plus this much. This angle is theta. Okay, and this length is L by 2. This is L minus x. L minus x. So this length is L by 2 minus L minus x. So L by 2 minus L plus x.
So L by 2.
X minus
This is obviously L by 2.
So the corresponding angle for y
So what is the height above this? Hence, let this height be h dash. H dash equal to h this much plus this small, which is L by 2 minus L plus x into tan theta. Is it okay? Perpendicular by base equal to tan theta. So perpendicular equal to L by 2 minus L plus x into tan theta equal to h x minus L by 2. Okay. So what is the pressure at this point? Hence P pressure at, suppose this point is suppose M. Pressure at point M, pressure at equal to H dash rho L into G. Acceleration is in this direction. That will not have any effect on, not that M into A will not act here. H dash into rho L into G equal to H plus x minus L by 2 A by G into rho L into G H rho L G plus G cancel x minus L by 2 a truck carries a water tank or a tank of size 1 meter by 1 meter by 1 meter, 1 meter by 1 meter by 1 meter dimension of size 1 meter by 1 meter by 1 meter, which is completely filled with water. Completely filled with water, and there is no lid. Means open tank, completely filled with water. Then the truck starts accelerating, or truck starts with an acceleration of 5 meter per second square, 5 meter per second square, which is its maximum acceleration and also the maximum retardation, which is also its maximum acceleration and also the maximum retardation. Find the volume of water that will reach the destination. First you draw the extreme situation. Extreme. That drawing is required. Extreme situation. When it applies brake, liquid overflows in forward direction. When it accelerates, the liquid overflows in backward direction. After all this overflowing, the extreme situation, ultimately it will look like this. It will look ultimately, this is the extreme. Once it becomes like this, no more liquid will overflow. Once it becomes like this, no more liquid will overflow. This tilt may go in forward direction or it may tilt in backward direction, but already it has touched the end, so no more liquid will overflow. This is the extreme situation. So this angle is also known to you. So you should be able to find tan theta equal to A by G. Half. So now how much liquid? So when you calculate the volume of this portion, you have to subtract this. Okay. This is known to you. 1 meter. This is known to you. 1 meter. You can easily calculate this because angle is known. So suppose this is y. Y. So tan theta equal to y by 1 perpendicular by base. Tan theta equal to half or y equal to half meter. Half meter. Now this is the trapezium, so we can find it. Area of cross section. Okay. So area of cross section. What is the area of cross section? Half into sum of the parallel sides. Parallel side is 1 plus 1 plus 1 minus y. 1 plus 1 minus y is this much into the distance between the parallel sides, which is 1 equal to y is how much? Half. The 2 minus half 1.5.
1 plus 1 minus
1 plus 1
minus half 1.5 3 by 2 3 by 4 3 by 4 meter square. And what is the length of this side? It is 1 meter. 1 meter. So volume means volume that will reach destination equal to 3 by 4 into 1. So it does not depend on the number of times he accelerates or number of times he accelerates, because this is the extreme. See, once this is the extreme. Okay, once it attains this state, no extra liquid will overflow. Okay.